Hello students, the next part in the criteria is surfacing, and this video is very much useful for a beginner who really don't know what exactly surfacing is. Now coming to the example of the surfacing, a car body, that is bonnet, is one of the familiar example of the surfacing. Then the front door, rear door of a car body. Then a mouse is example of surfacing. Then jar, badminton racket. So many are the example of surfacing. So by using the surfacing, one can come up with the same. Now, so let's start for the surfacing. So here, go into the start, mechanical design, and go here as a wireframe and surface design. The same window will appear as that of a part design. Only difference is that in a part modeling or in part design we have the padding, pocketing, then solid combine. So many tools are there, and here we have the different toolbars and different commands. It may be the extrude, it may be revolve, it may be a cylinder, so and so far. So let's start. Say OK. Now see, these are the different toolbars of the surfacing. That is simply surface operations. This is the extrude, which simply extend or simply extract my particular profile. This is simply a revolve through a 360-degree to any angle. This is simply a spear. This is a simple cylinder. This is the offset one. This is the sweep one. This is the filling one. This is a multi-section surface, and this is a blend one. So these are coming in the surface toolbar. Here we have the operation one, and in operation here we have the join. Under this one we have again the helling, then untrim, and this disassemble things commands are there. Again here we have the split and trim. Here we have the simply the boundary one, and here we have the extract, and again here we have simply a translate, a rotate, symmetry, then it is a simply a scaling, affinity, axis to axis, and here we have the extrapolate. And similar to that of the part modeling, here we have the point, line, and plane. And apart from this, here we have in the wireframe one. This is a simply a projection. This is intersection, circle, and a spline. So near about the few commands, I say the few commands are similar to that of the part modeling. Here the part of the surfacing is here, so we require basically these commands, starting from this the extrude to the blend one. Now we will see one by one. Now similar to that of the part modeling, let's select the any one plane. I'll say XY plane and go into the sketcher domain. Now come up with a simple sketch. I'll draw a simple sketch without any constraint, means dimensional constraint. You might aware that what is a profile toolbar, what are these things are here, because you are already aware about the part modeling, so you very well know about each and every one. Okay, so this is my sketch without dimensions. I'll say exit a workbench. Now I simply call this as extrude one. When I call this extrude one, similar to that of the padding in a 3D model, where we have the limit 1 and limit 2 with different dimensions, right? Okay, so first we select the profile. This is my profile, and yeah, the direction is along the XY plane, because my sketch was on XY plane, because initially I select this XY plane. That's why by default the direction is XY plane. Now If you want, you can extract by holding this one, and see here dimensions are changing 50, 60. Similarly for this one, or you can directly type over here as maybe 50. If you want second direction limit, say put a value, otherwise say 0 and say OK. Now this is simply a surfacing. Now if I compare this with the 3D model, in the 3D model I will get the entire as a solid one, but here I am getting as a surface one. So that is a basic difference between the 3D solid modeling and here surfacing. The name itself indicates the model which we created in the part modeling, that is a 3D, is one solid one, solid modeling, and here is simply a surfacing one. So like this you can create any kind of shape, right? So this is simply the extrude one. Okay, I'll simply go with the control site. Okay, I will come up with one more sketch over here. We'll come up with a rectangle and see, select this one. Now this is my rectangle, which is not a solid. This is the entire the hello one. I means this is the speciality of the surfacing one, I say, because the part, this part, see, this part is completely hollow. If I see like this or like this part is completely hollow, so that is called as a surfacing, which only create a surface, not the 3D solid model. Okay, so I will give you the one more thing over here, that is I will show you the how the fill command works. When I select this one and when I select the boundary, now see here is empty. When I select the boundary, now see the sketch one is appear. And as I told you earlier that this is very useful for the beginner who really don't know about the surfacing, right? And so when I click on the OK, see what happened, the face this get closed one. If I see on the others from other side, now see this get closed one. So this is the use of this one, that is fill option. Similarly on this side I'll also go with the same. Now I think it is part of extrude one, so it's not possible. Okay, so I will try once again, no problem. See the red color comes over here, so yeah, now it is there, because the selection is very important. As I selected earlier the only a single line, so when I select a single line without selecting the profile, because here I selected this a profile, but here no profile, here is only the extruded part of this one. So when I select the first one, okay, I will show you control side. Yeah, when I select the first one, the red line or red message appears, that is the open edge gap, right? When I select the second one, similar to this one appear, third one and fourth one, like okay. So the thing is clear to all of you that the selection is very important, because this sketch is here and here is no sketch, here is only the extruded part is there, so that's why the problem may occur. So you can handle the problems like this as I shown you, like okay. Now we'll simply delete this one. I hope that this part extruded one and the fill is clear to all of you. So I'll delete the geometry. Okay, now I will switch on to the next command, that is simply the revolve one. Now if I click on this revolve one, see what happened, it simply requires a profile on the revolution axis, and here we have the angle 1 and here we have angle 2. So the total cumulative is near about 360 degree. It not be more than 360 degree, but it should be less than 360 degrees. Okay. Okay, so the first I will come up with the profile and then come with the revolution axis. Yeah, so I'm not explaining about these things to you because you are aware about the things. So I will simply draw the sketch over here. Simply drawing the simple sketch over here. Yeah, we'll try to show you how to draw a jar little bit. Yeah, okay. So this is my profile without dimensions, and this is my axis of revolutions. Exit workbench. Yeah, the revolve. I select this, and by default during the sketch I drawn one simple axis, so that axis is considered as a default here, default sketch axis. Now if you want, you can change the angle. See, the angle second is 32 degree. If I holding this and dragging this, change angle 1 is also going to change, right? So in this way you can come up with the entire revolution of surface 1. But listen, the entire part of this, even though I've made this as a 360 degree, the part inside is completely hollow one. So that is the specialty of the surfacing one. So part is hollow. So that is the use of the revolution. We required the one profile and second the revolution axis. Okay, cancel, because I want to go for the next one. Again using the same things, I'll go for the sphere one. And for sphere we require the center and the sphere axis. So I'm selecting this as a center. Now see, by default it consider this as axis. If I want, if you want that, you can reduce the radius here, not diameter, radius. Now this is simply the merge end, merge start, and part end, parallel start, parallel end. Here are the different angles. If you want, you can change it, no problem. And if you select this, now see what happened. The sphere get closed. But remember, the inner part or inside part of this is again the hollow one. So that is the use of a sphere. Again, consider the default axis. If you want, you can change the axis by right clicking over here, create axis system. So that is use of the sphere one. Now next one is simple, the cylinder. Again here required the point and direction. This is my point. If I am selecting this direction, now see what happened. My cylinder will form like this one. I reduce the radius so you will understand clearly. So this is the radius of 4 mm, means diameter of 8 mm, as this one is cylinder. So obvious, for this cylinder diameter is required or radius is required. Again you can change the length, 20, you can vary the length, no issue. Okay, if I change direction, now see what happened. Right now I'm selecting, my selection was this one. If I change this one, now see what happened. Yeah, it's Y. So it depends upon your selection. If you select the horizontal, the cylinder may get like this one. If vertical, cylinder may like this one. If you give your own axis, then the cylinder may be according to your axis. So this is the use of this particular cylinder. I'll say OK, and I will simply delete this one. If I delete this one, see what happened. The entire sketch may get deleted. So before deleting the things, you must aware that what you are going to be delete and what its effect on the other things. Okay, next one is this offset one. Okay, offset means simply giving the some suitable distance and deleting the same one. When I select this one, and if I giving the offset one, see 15 mm. Yeah, see, this is the offset. You might aware what offset is. So this is the offset one, right? It always not be the cylindrical one. It may be a rectangle. It may be of any kind of geometry. We can do the offset one. Okay, now this one sweep, this multi-section solid, and this blends are remaining, so that I will cover in my next video. Okay, so thank you very much.